In yesterday's lesson, you saw how to find the domain and range for a square root function. Today we're going to be continuing to practice domain and range, but today we're extending it into two more functions that you already know. We're going to be dealing with quadratics like this problem and absolute value equations. So first up, to do this, we got to remember what domain and range are. Now you should already have these in your notes from our last lesson. The formal definitions of domain and range here. Now, just to kind of give you a little bit more depth, a little bit more of a way to look at these two ideas, here's kind of a step-by-step process you can add to your notes as well on how we find domain and range. Because we saw yesterday that the first thing we did was we make the graph. Because if we can visualize the graph, we can then see what the domain and range are. Because the domain is just a description of which x values are included on the graph. And the range is a description of which y values are included on the graph. So if you can see the graph, you can pretty much see the domain and range from that. All right, so let's go back to our original problem here. So the first thing I want to do then is I want to be able to see what the graph looks like. So the plus 1, that's going to move my graph left 1. The minus 6, that's going to move my graph down 6. So that's the first thing I do here, left 1, down 6, plot the point. And then I can see that this is a quadratic equation because it's squared. The squared tells me it's going to be the parabola that is also called the U-shaped graph. And so that means I go over 1, up 1 on both sides. And I go over 2 and up 4 on both sides because 2 squared is 4. And I go over 3 and up 9 on both sides because 3 squared is 9. And over 4 and up 16 on both sides as well. That gives us our graph here. Now that I can see the graph, I can now start figuring domain and range. Now domain, let's see if you remember, is domain the x or the y? Yeah, domain is a description of the x values. So that means it's got to be the x's, and then it's got to be greater than or less than wherever I start, right? Well, where does this graph start? Well, okay, so the first point we plotted was this down here, but notice from that point, my x's, it's going both left and right from there. In fact, as it goes to the left, it keeps going to the left. No matter how far left I go, if I square that number, I'm going to get a y value. There's going to be something that goes with it. What about as I go to the right, though? The same thing happens. No matter what x value I plug in over there, if I square it, I'm going to get a y value that I can actually plot. So all of a sudden, we see a different domain than what we've actually seen before. In this case, our domain is not going to be x is greater than or less than anything. Because our domain really includes absolutely everything, we say that our domain here is all real numbers. That's math speak for just saying it's everything. Our domain includes every possible x value that we could have. All right, so now let's go on to our range. Our range, again, we can think of starting at that vertex down here. And if I start at that vertex, notice I'm going up from that point, but I'm not going down below it. So my range is not going to be all real numbers. My range is going to basically be saying it's the y values that start at this point and then go up from there. Well, that point, that y value, is at negative 6. And since I'm increasing from there, my y values are all above or at that point, it's a greater than or equal to. So that then gives us our domain and range for our parabola. One thing you're going to note is that every time we have a quadratic now, every single one of them goes forever left and forever right. So every single time that you give the domain of a quadratic, it is all real numbers. Next up, let's take a look at an absolute value equation. And again, we can start by graphing it, and then as you become more and more well practiced at these, you'll be able to just visualize the graph to be able to find the domain and range. All right, so to graph it, the minus 5 moves it right 5, the plus 2 moves it up 2. So my first point goes right 5, up 2, and then it's positive, and there's no stretch or anything, so that just means go over 1, up 1 on both sides. And that's going to give us our V-shaped graph. Now that I have that, I can talk domain and range. So domain. Again, our domain is our x value. And so, again, I tend to think of the graph starting here at our vertex, but this one also goes forever to the left. So there is no minimum x. It keeps going forever to the left. As it goes to the right, again, it also goes forever to the right as well. And so there's also no maximum x. For that reason, our domain here is again going to be all real numbers. That is to say, x can be anything. All right, next up, the range. The range, again, it's not going to be all real numbers because you'll notice for the range here, it starts at the vertex and then my y values go up from there, but there's no y values below that because there's no graph below that. So my range is my y values. My y values start here at 2, and then they are increasing from there, so it's greater than or equal to 2. All right, having seen one of each, we can now start playing with these a little bit more. We're now going to find the domain and range of this graph. So again, I want to start by actually sketching out what this graph is going to look like. So the -4, that moves it right 4. The -1 moves it down 1, so that gives me my vertex. And then having plotted my vertex, notice we got this negative out front of it. That tells me then that my graph is going to be opening downward. So we're going to be looking at something like that. This is what we actually get when we plot each of those individual points. Over 1 down 1, over 2 down 4, over 3 down 9. All right, so now domain and range. Domain, hopefully you already know what that is off the top of your head because it is an x squared graph. It is a quadratic. That means our domain must be all real numbers. All right, and then for the range, well, we start this vertex, and then notice our y values in this case are all going to be at or below that point. So my y values, they start at -1, and then since they're going down from there, it's a less than or equal to. All right, and finally, one last one here to do together. We're going to take a look at what the domain and range would be for this function. Again, I want to start by plotting the points and seeing where it ends up as the graph. So the +7 moves it left 7, the +3 moves it up 3. So first point. And then the -2 here, it does affect the graph. And so instead of over 1 up 1, the -2 tells me over 1 down 2. And it is the V-shaped graph, so it's going to be doing that on both points, on both sides rather. And it just keeps following that same pattern as we go down. So this is what our graph looks like. Now domain, we saw earlier absolute value had a domain of all real numbers. And anytime you see an absolute value graph, it's going to be all real numbers for the domain as well. Next up, for the range. The range, definitely not all real numbers because you can see that our y values start here and then they go down from there. So my y values, they start at 3, and then since they're going down, that means a less than or equal to. And just like we saw when we graphed square root that had a vertical stretch on it, the vertical stretch here actually did not affect either the domain or the range. Really, the things that are affecting the domain and range are how far do we shift it over, how far do we shift it up, and then finally just is it opening up or down, whether it's been reflected or not. So the stretches, thankfully, don't end up changing that along the way, which makes our lives a little bit easier